Bedford's algorithm, interquartile range with quartile approximation, and range mid-range with streaming computation. Discussion on scalability for large data sets. Um, Explain characterizing feedback dispersion. Three key measures: efficient, scalable ways to quantify variability in student feedback. First one is variance, standard deviation. Variance is equal to average squared deviation from mean. Standard deviation, square variance, square of variance, computed efficiently via Welford's online one-pass algorithm for numerically stable streaming computations. Basically, standard deviation is the square of variance. Next is interquartile range. Interquartile range basically is the uh, interquartile range is basically is divided data in four or three sets according to data. We will divide in sets, then computed using selection algorithm like median of medians, quicksort, or approximate quantile sketches. But minus is quartile 3 minus quartile 1. रेंज मिड रेंज क्या होता है मैक्स माइनस मिनिमम मिड रेंज इवन डेटा सेट्स है तो मिनिमम प्लस मैक्स अपॉन 2 कर देंगे ऑड है तो मैक्स माइनस मिन कर देंगे ठीक है डिस्कशन फॉर वेरी लार्ज data sets prefer streaming one passed algorithm this next detecting skew and outliers in feedback ratings, statistical summary and plots for 27 sorted ratings, scale 1 to 100, highlighting central tendency, spread, and outlier. First, datasets and basic statistics. Given sorted ratings दी गई हैं. Mean sum upon 27, that is 29.96296. Sum this is given mean range and quartile mid range क्या है 41 30 plus 70 30 plus 70 upon 2 41 that is 41.5 quartile CA Q1 median of lower half was 13 20 then Q3 upper half 35 5 number summary minimum quartile 1 median Q3 max 3 minus 23 whiskers and outlier detection whiskey is lower to 13 upper to 17 QQ plot versus quantile plot explanation. Quantile plot, this is QQ plot compares this. Quantile plot template CDP box plot shows sample quantiles, VS values. QQ plot compares sample quantiles to hierarchical distribution. Next is calculate median satisfaction score from group feedback data. We have to find median. Score range with frequencies दी गई हैं total student 2994 median position NY2 1497 cumulative frequency shows median lies in class 2150 approximation median calculation by linear interpolation inside median class 21 minus 50 class interval 20.5 minus 50 20.5 to 50.5 तक है width 30 है lower boundary is 20.5 cumulative frequency before median class 750 class frequency f is equal to 1500 median that is median position minus cumulative frequency upon class frequency into class interval that is 35.44 approximation median satisfaction score is equal to 35.44 we are fine through this next to lifelong learning statistical snapshot lifelong learning feedback here data is given ages and productivity of their age mean दी है 40.44 summary statistics total number 18 से 18 data sets दिए गए हैं इसमें से age mean लगे 40.44 years median है 51 age sample standard deviation है 13.22 productivity mean 28.67%. Productivity median 30.7% and productivity samples standard deviation 9.21. Age box plot quantile 1 computed from data median 51 is Q3 minus Q1. Age whiskers we can find through this. Then Q minus Q plot. Productivity Q plots. Compute dissimilarity between student feedback profiles. Similarity we have find already similarities. Now we have to find dissimilarity between student feedback. First methods, practical methods for comparing nominal, binary, numeric test feedback. First method to compute dissimilarity between student feedback profiles. First is nominal attributes, matching coefficient or simple dissimilarity. T is equal to 0 if same, 1 if different. सेम होगी तो 0 होना चाहिए और 1 if different. Average mismatches for multiple nominal feeds, normalized Hamming distance. Asymmetric binary attributes क्या है? Coefficient let A both 1, B is equal to in X only, C is equal to 1 in Y only. Descartes similarity A upon A plus B plus C. Dissimilarity is equal to 1 minus Descartes similarity, that is equal to B plus C upon A plus B plus C. Numeric attributes क्या होंगे? Scaled Euclidean distance after normalization, min max or z score to avoid scale domination. Term frequency test feedback convert to TF or TF IDF vector. Use choosing similarity quotient for dissimilarity option. Optionally Jaccard on tokens or embedding quotient similarity for short feedback. Compare student faculty feedback distance measures between two tuples. We have to find, compute and interpret in Euclidean Manhattan and Minkowski and distance for two interaction tuples. Student faculty interaction tuples x is equal to and y. x and y दिए गए हैं, tuples दी गई है x and y. Euclidean distance क्या है? Square of 20 minus 22 minus 20 का square plus 1 minus, we have find here Euclidean distance through this formula, and Manhattan L1 is equal to 11, minus Q is equal to 6.9, and supremum is equal to 6. Next. Use the median for robust central estimates in skewed data. Why median is sketching work better than the mean for long tail. Median is a robust central indicator. Median resists effect of outliers better than mean, whichever when data is skewed or long tail. For massive datasets, approximate median using sketching, quintile, summarize, like t-digest, balances accuracy and memory efficiency for tail distributors. Analyzing student faculties and similarity, distance similarities, and ranking. Exact distance matrix rankings before the after normalized student attribute vectors. Here's the table given to find student vectors, Euclidean Manhattan supremum, similarity, their similarity, distance to. Ensure reliable feedback, key data quality dimensions, evaluate ratings, respond to trust insight. Accuracy, our ratings triple. Completeness means missing responses. Consistency, contradictory answers. Timelines, feedback collected near event or teaching. Validity representatives, whether respondents represent the population or based sample. Practical strategies for handling missing data feedback. Choose imputation approaches that balances simplicity, bias, risk, variance, impact. Ignore simple but bias risk of missing not random. Manual fill, impractical for large data. Constant imputation, example 0 or neutral. Mean median mode imputation reduces variance. Class specific imputation, group mean median per course department. Regression predictive models predict from other attributes. Multiple imputation introduces uncertainty properly. Most probable value KNN imputation, nearest neighbors approach. Refine feedback ratings, smoothing outlier detection for cleaner insights. Smoothing ratings using bin comments. Choose bin width and number of wins. Replace values in wins with win mean or median to reduce local noise. Apply smoothing over multiple depth passes for refinement. Outlier detection using Z-score threshold. QK fancies 1.5 into IQR. Robust methods like median absolute deviation. Ensure clean, trustworthy data for MCA, MT Tech feedback analytics. Practical integration step to line schemes, remove redundancy, resolve conflicts, and track provenance. Scheme alignment, matching attribute names, data types, units, handling redundancy, detecting and collapsing duplicate records using unique stable keys. Conflict resolution, trusting most recent majority or verified entries. Prevents tracking and retaining data originals for audits. Normalize feedback data for consistent analytics. Min-max normalization, x1, xmin minus xmax minus maxmin scales data to 0, 1. Z-score normalization, that is mean zero deviation. Z-score using mean absolute deviation meant for robustness. Decimal square divided by 10 to the power so that max. Normalize faculty workload for fair feedback analytics. Step-by-step min-max 0-1 scaling example using hours per semester. Example normalization of faculty workload using min-max 0, 1 data 200, 300, 400 data is given. Min-max value and range we have find. Normalized values 200 to 0.00, 300 to 0.14. Using formula we have to find normalized values. Next, normalization of rating value 35 for Q2 data set. These are the values given. We find normalized rating value. Z-score find कर लिया, decimal scaling कर लिया, divided by 100, 0.35. Which method is most appropriate? Min-max good for bounded, 0-1 sensitive to next stream. Z-score preferred for methods requiring mean, standard deviation, robust to outlier. Decimal scale is simplest but less common. Normalize using A's and normalize and correlate A's versus productivity insights. Using A's productivity data from quantile 4, normalized by Z-score. Formula formula is given. We have to find Z is Z productivity I. We have find Z productivity, person correlation coefficient, sample covariance, age productivity का sample find कर लिया, R covariance by so as standard deviation age into standard deviation productivity is equal to 0.813. Interpretation: older participants tend to have higher productivity percent in the sample. Compare winning methods for feedback scores to reveal natural groups. Show how equal frequency, equal width, and k-means clustering partition the same score set and what each reveals. Partitioning project evaluation wins. Here data is given. Equal frequency 3 wins of 4 elements each. We have divided data in 3 wins. Equal width range by 3. Width is equal to 70. We have 5 win 1 range 5,75. Win 2 75 into 145, that is 92. Win 3 ke liye 204 into 215. Clustering K3 is K is equal to 3. Cluster 1 low, mid, and high. Discussion: equal frequency balances bin sizes. Equal width preserves numeric scale interpolation. Clustering captures natural grouping based on gaps. Select the right attributes to boost feedback models. Practical flow of forward, backward, and hybrid selection for cleaner and better performing features. Forward selection: start empty, add attributes that improves model by creation criteria. Stop when no improvement. Backward elimination: start full, remove least useful attribute by p-value, AC validation, loss. Stop when all meaningful. Hybrid: stepwise, combine forwards and backward step, balances selection and pruning. 3 right attributes